Great. All right, hello again, everybody. This is our periodic webcast. And what I thought I'd do, I'm going to go over some of the questions on the quizzes that caused some problems. But first, I want to get to a basic question that comes up, and comes up a lot, actually. And the question is, so if you were going to give me a simple answer, of course, hard for a professor, but if you were going to give a simple answer to the question, what two things do you want me to get out of this course? What would they be? Well, that's a really good question. There are two things I think that I'd like to get across, and that I hope the course does. The first is to encourage you to think of yourself and to become a problem solver. Now, that sounds really easy, but it's not. And it's not because the kinds of problems that really concern the world today, everything from distribution of wealth to climate change, to the conflict situations around the world, to the continual tug between developed economies, between cultures of different countries, activism of all kinds. All of these pressures and trends mean that the problems that we really need to deal with are non-trivial and not easy. If the problem I give you is, what size bolt do I need to put into this bridge at this point? That's easy. That can be done. And in fact, a machine can do it, which is why you probably don't want to be doing just that in your career. But the bigger question, how do I solve problems? That's much more difficult. There's a tendency in a lot of education to give you answers. And that's fine if it's the kind of course where that applies. If, for example, I'm teaching math, 2 + 2 always equals 4. Unless you're in various strange kinds of math, but we won't even get into that. If I give you a question in grammar, verb, noun, what does this do in this particular grammar, then there's an easy answer to that. Well, let's look at some of the things you've already seen in this course and ask yourself, what kind of easy, definitive answer is there that's objectively, clearly better? The answer to that question is very hard, and it's very hard for a number of reasons, including the fact that as you get more and more into technology systems, you necessarily get more and more into values. And once you get into values, telling people what to think is not only ineffective, but can in fact be a significant cause of conflict. So for example, let's say that I were to present a complex technology, birthing Neanderthals, and I were to give you my opinion as if it should be your opinion. I think we should do this. We should not birth Neanderthals. There may be some technical advantages to doing it. There may be some knowledge gain, but we shouldn't do it. Well, the problem is that what I have done is I have gone from giving you a factual predicate for your decision making. So for example, can we birth Neanderthals? Well, there's some significant technical issues, but conceptually, theoretically, right now, there's no reason we couldn't work towards that goal. That's a summary of the facts as they're understood. But when I go further than that and tell you what you should do and what you should believe, then I am telling you what your values should be. Now think about this course. It has many thousands of students from all around the world. No country, including the United States, has any more than a quarter in any of the classes I'm aware of, certainly none of the classes I've taught, and it's usually significantly less. So what you have are people of many, many different cultures listening to this. And you have people with significantly different problems in their daily lives, in their working lives, significantly different frameworks for the world. And frankly, many people who are listening to this broadcast are probably better at some of the technologies than I am. Those of you that are younger, and I imagine that's quite a few of you, are going to be living in a very different world than the one I grew up in. So my ability to tell you what to think, particularly on values, should be regarded very, very skeptically. And in fact, I hope you don't do that. But I do hope you learn to operate effectively in a world where there are many different values, because that's an objective feature of the world you're in. You may, as a person, want to change it, and that's fine. You may be an activist and you want everybody to assume your particular belief structure in this particular area. You may come from certain religious traditions, whatever it is, that's fine. But the point is that the world doesn't have a unified belief system of any kind. So what that means is that what you have to do if you're going to be effective on these broader problems is you have to be able to work with many different systems, not believe them, not adopt them for yourself, but work with them to create solutions that make everybody better off to the extent that you possibly can. That's a problem solver. And that's what this course is trying to get across. So I'm not trying to get across this is how you should think, because that would be ineffectual and dysfunctional. What I am trying to get across is if you want to be effective in solving the complex problems that this world needs progress on, you're not going to do it unless you can learn yourself to be an effective problem solver. So number one, I want you to be an effective problem solver. What's the second? The second is, even though this course focuses on certain themes, technologies, the sustainability issues, and social to some extent, none of those systems exist alone and in a vacuum. And again, the more you look at the complex problems that our world is dealing with, the more that becomes obvious. But let me give you a historical example. The Industrial Revolution happened about 1720s to 1750s in the United Kingdom. Why? Why didn't it happen, say, in Sung, China, which about 960 to the 1200s? They had the metallurgy, they had the knowledge, they had large manufacturing centers, but there was no industrial revolution. Didn't it happen in the Roman Empire? They were large, they were rich, they were wealthy, and they were certainly good engineers. Why didn't it happen then? Or say later on, the Dutch during the 1600s, when the Dutch Empire was really at its height, when the Dutch, in fact, were establishing a global empire. For reference purposes, the Dutch East India Company was founded in 1602. Why didn't it happen then? Now, to answer that question, you can, if you want, look at only certain domains. An economist might say, for example, that it's because the United Kingdom, uniquely at that time, had a very broad and deep capital structure that enabled funding of factory capitalism in ways that, say, the French were not capable of doing at that point. So that it was the capital structure, the sophistication of the capital structure in the UK. That's a good economic explanation, but it fails. I mean, the Dutch were very sophisticated in their capital structure, and before that, the Italian city-states in the 11th and 12th and 13th centuries were very sophisticated in their capital structure. So why didn't it happen then? And of course, Rome had plenty of resources. So did Sung China. Well, another argument is resources. The United Kingdom had readily available coal, and importantly, also had wool and a trade system that could provide cotton, that provided textiles, that provided the core of the first real industrial system, which of course was cotton textiles in the UK. Well, fine, but there's plenty of other places that have resources. Now, a lot of places don't have the resources that the British had easily available. But coal is not something that is hard to find. Well, maybe it's the technology. The technology finally got to the point where you could have an industrial revolution. Most people wouldn't buy that simply because the technology is, the societies we're talking about had very sophisticated technologies. Assume China, for example, or the Romans certainly had good technology. Some of it been good enough for an industrial revolution. So for example, if you assume that an industrial revolution requires steam and steam engines, you need to have good metallurgy. At the beginning of the Industrial Revolution, as most of you probably know, there was a pretty dramatic failure rate of the steam engines because steam, of course, operates under pressure, and the iron they were using simply wasn't good enough for the kinds of boilers and the kinds of devices that they needed. But it's probably not just technology. So what is it? Well, let me sketch some of the things, and it's not complete. I mean, obviously you can't answer a complex question like that, even in a full course. But let me sketch some of the things that tied into why you had an industrial revolution and why you had it in the UK. One of the things is that you had fundamental shifts going on that supported the possibility of an industrial revolution. For example, let's assume that resources is not an issue, which in most of the places we're talking about is a good assumption. You need an agricultural revolution that allows you to free up people from the land from doing agriculture so that you can have people in your factories and your facilities, but at the same time allows you to maintain agricultural production. So you need an agricultural revolution as part of the early foundation for an industrial revolution, which is fine. But then, of course, you have to have a population boom if you're going to get the excess labor that you're going to use to support your factory system. Now, had this happened in the past? Yes. What happens when you have a population boom and you have no industrial revolution? You have famine, and the people die. So you had these kinds of structures, but now they're coming together at a particular point in time, because you have the agricultural revolution freeing up labor, creating enough food for a population explosion, so it creates a pool of surplus labor, and importantly, it also creates demand. Most people tend not to think of this, but if you have an industrial, let's say that you're the United Kingdom, and you're producing cotton using your new machines, enormous amounts of it, and nobody wants to buy it. There's not enough people, they don't have enough money, nobody wants to buy it. No, you don't have an industrial revolution. Why? Because you don't have any flow of capital back to reinvest. You have no demand. Even today, when demand falls, you tend to have recessions. So you have to have demand. So all of these things need to function together. But that doesn't explain why, say, the UK and not France. There you get into specific kinds of institutional issues. For example, the United Kingdom did have the best and deepest capital structures, most sophisticated ones in the world at that point, so that they had capital that could be made available. Importantly, the mercantile class was not looked down on culturally as much as in other European countries, which meant that, for example, the landowners, at least the ones that knew what they were doing, invested in these factories. So the landowners, instead of being the ancien regime as in France and trying to maintain a rural agricultural structure, fed money, capital into the new factory structure. And you began to get urbanization, surplus labor, centered around factories in cities creates urbanization. Again, not new, but at scales that we really hadn't seen before, in doing things that we hadn't seen before. And you also have, particularly in the UK, a laissez-faire approach. One of the things that you tend to see is that in cultures that are very conservative, very strongly controlled by a particular belief system, you don't tend to get the innovation, you don't tend to get the creativity. The easiest contrast here is probably Catholic Spain with the Netherlands, eventually France, Belgium, and the UK. Because there was no controlling entity in the UK, there was nobody that said, you can't do this. There was no conservative structure that was able to completely dominate activities across the United Kingdom. There was room for people to experiment, to do new social things. Even if most landowners, even in the UK, didn't approve of industry, it became possible. And once it becomes possible, then people can start working on it. So that you have a culture that is laissez-faire enough for the entrepreneurs who want to build these kinds of systems. Josiah Wedgwood, for example, who created an entire vertically integrated structure to make China. You have these people able to do it in the UK, not just because they have capital, not just because they're entrepreneurial. I dare say most cultures have entrepreneurial spirits, but because everything comes together and allows them to succeed institutionally at scale. And that was something they probably couldn't do even in most places in Europe at that time. So why are we talking about the Industrial Revolution? Well, we're talking about it because it's a very complex problem. And what it illustrates is that while any particular perspective can give you good information about why the Industrial Revolution happened in England, none of them are sufficient. That is to say, do I need surplus labor? Well, yes. To get surplus labor, do I need an agricultural revolution so people are leaving the land, but I've also got enough food? Well, yes. Do I need to have urbanization? Well, yes, you have to have labor centralized, which of course gives rise eventually to the working class, as Marx predicted. Do I need deep capital, laissez-faire economics, not too much government regulation? All of it, absolutely, yes. So it all comes together, but it all comes out of different domains. So if you want to say study the British capital system for your PhD, great. That's a very focused target, and you definitely want to look at it as an economist and historian looking at that particular time and very specific issues. But if you want to solve problems, you need to be able to take that broader perspective, because with your problem, all of these are going to come in. One of the reasons that climate change has been so difficult politically, culturally, and socially is precisely because at the beginning, we defined it only as an environmental problem. And we expected everybody to salute and follow. And they didn't. We should have known that. From the beginning, if you look back now in hindsight, from the beginning, we set up climate change policy to fail. And sure enough, it did. So that's why it's important to understand the complexity of the world that we live in and the way it's interconnected. So, first basic point of the course, try to be a good problem solver because the world needs you. Second basic point of the course, understand that while you may want to take particular perspectives given the problem that you need to solve, all of these systems are interconnected. And they're interconnected in the real world, which means that if you try to avoid it, you can't. So those would be the two that I would start out with. Okay, let me start with a couple of the go through a couple of the questions that people had some problems with, and let's see what we can do with some of these. Okay. It is quite clear and easily demonstrated that materials which are more toxic pose greater risk to humans. This question turns on the difference between toxicity and risk. So plutonium is very, very toxic. On the other hand, almost nobody dies from plutonium poisoning. Why? Because it's very carefully controlled. Toxicity is an inherent characteristic of plutonium, but if plutonium and the population that might be injured never touch each other, then you're not going to get significant risk. Where this argument plays out in practical terms, again, the argument between inherent toxicity and risk, a lot of times is in regulation. For example, there's certain materials that are risky, that are toxic, but they don't readily appear in people's environment, or they may appear and you can regulate the use rather than the material itself. An example is arsenic. In the United States, arsenicals, that is arsenic-based compounds, used to be used to treat seeds. That was a really bad use of arsenic, which is a toxic heavy metal. Because it meant that what we were doing was distributing arsenic widely in the environment, because we were putting it on seeds, and seeds, of course, go everywhere and get planted everywhere. So that was a problem. So the EPA, the US Environmental Protection Agency, moved to control that use of arsenic. The problem, and banning arsenic probably would have been difficult, because arsenic is a very useful material. In fact, you couldn't have electronics without arsenic. It's a common dopant in a lot of electronics devices. Dopant is a material that appears at very, very low concentrations in things like chips, silicon chips, or certain kinds of fiber, things like that. So, so with arsenic, you don't want to ban it, but you did want to control that use because it was a dispersive use. Well, what happens after we ban it in agriculture? The United States begins using it as a preservative for timber, for lumber. Well, that's a problem, right? Because lumber goes everywhere. It doesn't always get pulled back. And when it's pulled back, it isn't treated as a hazardous material. It's put in landfills. It sits around in vacant lots. It may get burned in your fireplace. So the problem is that we substituted one dispersive use for another dispersive use. And what that means is that the toxicity of arsenic remained the same. We controlled it when we reduced its use in agriculture, because that reduced exposure. But then we blew it because we went out and went ahead and used it in timber. Now you might ask yourself as an engineer, why on earth would I use arsenicals to preserve timber, knowing that? And the answer is that a lot of work on things like preservatives was done at bench scale, which means what you were interested in was how effective it was and whether it worked in a small laboratory environment. Of course it did. But laboratory scientists working on materials issues are not trained to think about broad environmental issues. And the result is that you get exposures that nobody had thought about prior to the deployment of the technology. So that becomes a problem. So the bottom line on that question is that toxicity is something you always want to keep an eye on, but it does not become a risk unless there's exposure. Okay, which of the following are scientists least concerned about in regards to GMOs? Runaway mutation, impacts on ecosystems and non-target organisms, the danger that GMO foods pose for consumers, and scientists are equally concerned about all these issues. Now notice the phrasing of that. You're looking for the least concern. Are scientists concerned about runaway mutations? Scientists are concerned about the possibility of mutations. Runaway is probably not an issue with GMOs, but mutations that you put into one species that may be able to jump the species barrier and get into other species, that might be a concern. So scientists would be looking at and certainly thinking about, as would regulators, mutations and whether or not the GMO mutations that you created were able to jump species, and if they did, what the effect would be. Impact on ecosystems and non-target organisms? Absolutely, right? You worry about that with new crops in new areas. You worry about it with taking out too many of the indigenous species. So yeah, you'd worry about impacts on ecosystems. The danger that GMO foods pose for consumers. Well, this is a non-issue, right? To the best of my knowledge, no consumer has ever died from eating anything that had GMO food in it. It's just is a non-issue. So why is it probably the biggest single issue in people's minds? It's because it's an effective way to if you don't like GMO technology, and GMO technology has two domains associated with it. One is sort of the objective analysis of what the technology does. And the other question is, should we be doing this at all? Is this a violation of the sacred? Is it essentially blasphemous? So you have a highly normative domain and you have an objective domain. In the objective domain, food is not an issue. Because there's as I say, nobody's demonstrated that GMOs raise any particular health issues as regards to food. But if you believe that GMOs are a violation of the sacred, food is a very effective way to make your argument. Because most people, if you tell them that you shouldn't do GMOs because it's a violation of what God wants, that gets you into the whole difficult question of what particular God are you talking about? What interpretation do you have? Which is an argument that at least in Christianity, which is the belief system I'm the most familiar with, at least in Christianity, goes way back to the 10th century. So that's been going on for a long time, even within Christianity. It's a very interesting twist now, because the people that make that argument as a religious argument tend not to make it as Christians. They tend to make it as a standalone argument of the sacred being the wilderness. So there's interesting variations. But the bottom line is, people are not going to listen to that. They will listen if you tell them that your food is being destroyed by faceless corporations, which of course makes this a very powerful public relations point. So that's why that issue is so high in public consciousness. And that's for example, another question that came up was the use of the term frankenfoods. A brilliant public relations term, a brilliant PR term, because what it does in a single word is it causes fear about something that people care about very much. People don't just care about food because they eat it. People care about food because food is a highly charged cultural item. Every culture has its own foods. And although we tend to think that we talk about it we think about our foods in rational terms, we tend to be very, very subjective when we talk about our foods. A lot of the argument between vegetarians and omnivores, for example, comes down to cultural issues about the role of meat in one's diet. So essentially, what you have with the third one is you have a seemingly objective argument that's being made for normative reasons, and very effectively too. So they're not equally concerned about all of the above. They're mainly concerned about the first two. All right. As a sustainable engineer, it is important to bring all relevant stakeholders in line with your expert worldview. Well, no, it's not. That would be like me trying to tell you what you should believe. I'm a white, older American professor. There are probably representatives from 70 countries that will see this tape. What on earth am I going to be doing if I try to tell all of you what it is you should believe? That would just be, it's foolish, because you all have different beliefs. We all presumably are self-selecting by working on the issues we're working on, but still you have very different beliefs. And the same is true with a sustainable engineer. Remember, the goal of sustainable engineering, and this is true whether you're an engineer or whether you're a technologist, a technology manager, or policy person listening to this, the goal of sustainable engineering is to achieve workable, desirable solutions in the real world. And because it's the real world, you're going to have to deal with different belief systems. It doesn't mean you need to believe them. And in fact, you don't want to think about believing them, because that might interfere with your ability to solve the problem at hand. Suppose you have, for example, perspectives that you disagree with strongly that still need to be part of the solution. Let's say, for example, that your job is to manage the Florida Everglades in the United States, which at the current, to vastly oversimplify, has at least three different interest groups that have very different perspectives. One is the agricultural interests that want to be able to use the water that flows into the Everglades. One is the environmentalists that want the Everglades kept the way they are. And one is the developers that want to be able to continue developing in Florida, which is very desirable real estate. All of those people have different values and different views. If you go in and try to impose your own view as the problem solver, as the person who's running the Everglades, you're going to fail. And that's why you don't want to do it. Because these other views, even if you personally disagree with them strongly, these other views are important parts of the problem that you're tasked with solving. Now, if you go in as an activist, that's a very different kind of perspective, or a lobbyist. So if I'm the lobbyist for Big Sugar or Big Ag in Florida, I'm going to represent their interests. That's my job. And I'm not going to try to be a problem solver for the whole overall system, although I may well participate in trying to achieve a solution that includes my views and the views of my clients. Okay. All right. Imperialist crops, mutant tomatoes, or frankenfood. If you just say those, you realize that frankenfood has a real impact that the others don't. I kind of like imperialist crops. If you're going to lobby against GMOs, that's as good a word as any. But frankenfood is clearly the one that you want to use. All right. Which of the following is an example of a disruptive technology? Now, remember that a disruptive technology is one that completely destroys the system that was doing that function before. It may do it in usually in a relatively short period of time. It may do it directly, or it may do it indirectly. So a disruptive technology, chemotherapy? Not really. Chemotherapy is an incremental advance in trying to treat a disease. And those happen all the time, and they're not disruptive. Now, in medicine, if I were to find a drug that enabled you to think 10% better than you do with no other impact, that would be disruptive. If I were to find a drug that extended everybody's life by 20 years, regardless of where they were or how they behaved, that would be disruptive. But chemotherapy is not disruptive. Plastic spoons, again, not disruptive. It's a technology that gives you spoons that you can take with you on picnics. So digital cameras. Now, digital cameras are one of the ways to look back and see if you had a disruptive technology is to look at what it did at the people that were using the technology that did that function before it. So the function before digital cameras, obviously, was film cameras. The ones that were made by people like Fuji and Kodak and Polaroid and other firms. What happened with many of those firms? Well, they've gone bankrupt. Polaroid went bankrupt, and Kodak is a very small shadow of its former self, and it does different things than making mass cameras, because nobody buys mass cameras anymore. Digital cameras have become so much better. Now, digital cameras are being disrupted, right? 5 years ago, if you wanted to go on a trip, you might have bought yourself a digital camera so that you could go on that trip. Now you take your mobile phone, because the camera on the mobile phone is as good as digital cameras were 5 or 6 years ago. So why not just take the phone? So disruptive technologies are the ones that break the previous patterns in significant ways. And the reason that that concept is important is, if you ever work for a company, one of the things that you want to keep an eye out for is precisely those kinds of disruptive technologies that come at you out of nowhere. I used to work for AT&T. And at AT&T at one point, we had, I would say, the world's best telephone technology, best telephone network. But it was telephone switches, and it was point to point. And the way it worked is, I would open up a channel to you every time I called you. And it was this type of technology. But along came packet switching. That is where my voice would be broken up into small packets of information and just splattered out across the network and then pulled together at the other end. Which, if you think about it, that's internet technology, right? That's Skype. That's this technology that I'm talking to you with. So what this does is this takes the technology that used to be behind telephone systems and completely disrupts it. Why does disruptive technology work? Well, the average cost plus or minus of a minute of phone call on the old AT&T network, domestic call, was about 10 cents. With the internet, it's about 0.01, 0.1 cent. It's trivial. What does that mean? That means that if you have a company that is established based on a technology that gives you 10 cents a minute, and new technology comes along which does it for about maybe a tenth to a hundredth of the price, the technical term for you is your roadkill. And that's what happened to AT&T. AT&T basically was going bankrupt. It was bought by another company that then relabeled itself AT&T. But the fact is, AT&T was done in by disruptive technology. Internet-based telephone calls were a disruptive technology. And AT&T, big as it was not able to stop that. We're seeing something similar go on, for example, with PCs, as people more and more migrate to mobile phones and to tablets. So these kinds of changes are important, because if you're working for a company, or if you're working for the government, if you're looking at your domestic firms, you need to be aware of these changes and these shifts, because it could have significant impacts on your economy and on your employment. All right. Seeing nature as only having instrumental value includes what? Okay, well, here the important thing, the answer to that was resourcism and preservationism. But the important thing with this question is to understand the difference between thinking that nature has instrumental value and thinking that nature has intrinsic value. Go back to the GMO food argument, right? An instrumental perspective on nature is, if GMO foods do the job better with reduced costs to human health, to the environment, then we should do GMO foods. An intrinsic perspective would say, no, there is something sacred about nature itself that that humans should not, as a matter of fundamental morality, play with. And to mess with nature at that scale is blasphemy. So the difference between those two perspectives is very great. Where does this come up? Well, again, let's say that you're negotiating over the future of the Everglades because you're the person that's been given responsibility for the Everglades. And you have in front of you 4 or 5 business interests, 4 or 5 agricultural people, lobbyists, and 4 or 5 representatives of different environmental NGOs. And if you're dealing with the Everglades, you're going to have some representatives of Native American nations as well. So, so you have all of these representatives in front of you. And your question is, what will the environmental community agree to? And some of them will say yes, if you come up with a reasonable solution. Some of them will say no, because their bottom line is that you're trying to put a price on something that has no price. You're trying to take the Everglades, which is essentially beyond economic value, and you're trying to give it an economic value so you can get me to agree to this silly thing you've cooked up. And I'm not going to do that. So that's a fundamental difference that it's very important to remember. Because if you're doing something that changes a natural system in the perspective of some of the communities, and they have an instrumental value, then perhaps you can find things that will allow you to compromise and develop a design, for example, that will be successful. But if you're dealing with an activist community that believes that nature has intrinsic value, then as a matter of fundamental morality and ethics, they may not compromise with you. And so you need to understand this difference in the way nature is perceived. And if you look around it, you'll see examples. And of course, those are the two extremes. There's a lot of people in the middle towards one side or the other. All right, what are some of the other issues? The hierarchy of control is a heuristic primarily concerned with, okay, remember what the hierarchy of control is. It's just a model of good ways to address potential risks. With any system, if you have a potential risk, the best way to address it is always to design the risk away. So let's say, for example, that I've got a factory and I'm manufacturing printed wiring boards, and I'm using chlorinated solvents. Chlorinated solvents, perchloroethylene and other trichloroethane, chlorinated solvents are generally not good because they cause air pollution and they can often cause human health impacts. So the best way to make sure that you've controlled that risk is design it away. So instead of having, for example, a chlorinated solvent cleaning machine that cleans your printed wiring board so you can put components on them and solder them, instead what you do is you develop a water-based cleaning system, a detergent-based cleaning system. And that simply gets rid of the problem. So that's always the most desirable. And that's a generalizable rule. Try to design out risks before they become problems. So obviously you want to do things like, all things equal, use less toxic materials. All things equal, design products that will last longer so that they don't have to be replaced as frequently. Although you have to be careful with that one. So you have these general design rules. The second level is that you want to think about doing things like personal protective equipment, things like that. And what you're doing here is you're recognizing the risk and you're putting in place technologies to mitigate it. And again, as a second step, that's a good idea. So let's say that you've worked as much as you can with the system, and now you want you've redesigned what you can, you've designed out toxics, you've designed in energy efficiency and so forth, but you've gone as far as you can. Well, to the extent you still have materials that pose risk, what you do is you begin to implement things like protective equipment and things of that sort. And generally the problem with the equipment is not that the equipment isn't good. The problem with personal protective equipment and those kinds of solutions is that workers can bypass them. And sometimes they do. They want to be more productive. They're just uncomfortable. So you want to just not use them. So they don't. And in that case, you can avoid the personal protective equipment. The third and the least effective in this gross overview is regulatory or rule-based intervention. And the reason for that is obvious. Because rules are more easily broken than personal protective equipment. Personal protective equipment, people know they should use it and you can get them used to using it. Rules, I mean, it depends on how much they're enforced. Some places enforce them, some places don't, and they're not as effective in general. They're certainly not as effective as designing out the problem in the first place. That model applies to a lot of things, but the hierarchy of control in particular is a worker safety institution. Okay, Tata Nano, a small economical car produced in India. So consequence, unequal access to private transportation is reduced. Motorcycles will no longer be used, potentially huge environmental impacts, all of the above. And the answer is there are potentially huge environmental impacts and unequal access to private transportation is reduced. Motorcycles will no longer be used. Well, no, I mean, motorcycles, of course, will be used. In general, when you're looking at tests of this kind, this is a non-substantive comment, but in general, when you're looking at tests of this kind, one of the things that you want to look for are blanket statements like that. X will not happen. And be skeptical of those, because anytime anybody's saying that, the obvious answer is, well, are you sure? Isn't there some corner where it might happen? And of course, with motorcycles, which are very popular means of transportation in many countries, they're not going to go away. So, yeah, there's that one. Okay. And finally, I'd like to close by talking about an article which raises a very interesting question, but also talking about how to think about articles in general. So let me raise two articles. One is out of an old issue of Science, June of this year, talking about federal barriers to cannabis research. And what this is basically saying is the federal government is throwing a lot of barriers into the way of trying to understand marijuana. And of course, that's because at the federal level in the United States, marijuana is a controlled drug. Therefore, to do research on it, you need to get permission from the federal government. And by and large, the federal government is only given permission for studies which are going to show that marijuana isn't a good thing, because they don't want marijuana to be a good thing. The people that are in charge of the research. So first question. Anytime you read an article, anytime you see something on the internet, the first question you should ask is this from a legitimate source? For scientists and engineers, the best source is a peer-reviewed article that comes from a record. That is a journal that exists in a particular field where people publish the leading findings in that field. The second best source are the smaller journals where you still do peer review. That is, peer review is when you send articles out and they're looked at by people who are familiar with your field, not to see if they necessarily agree with them, but to see if they're well done, if the analysis is good, if there's any mistakes in the way the article is put together and that sort of thing. So peer-reviewed articles are generally the best for factual information. And then, of course, there's the whole gray literature where people publish information from other sources. They summarize it. They talk about the implications. This can be fairly reliable, like for example, the news magazine The Economist, or fairly unreliable, as for example, in the United States, the National Enquirer and similar newspapers around the world. The point is that all of us today are caught in far more information than we're used to. In the 50s, the 60s, and the 70s, information tended to come with tags that let you evaluate how reliable it was. So for example, if you saw something, and again, I'm drawing on American examples because I'm more familiar with them. If you saw an article in the Washington Post or the New York Times, then generally it was pretty reliable. If you saw articles in lesser journals, lesser magazines, maybe not. So the first thing to do is evaluate where you find information, knowing now that there's a huge number of sources and there's a lot of made up information. Technology is changing so fast and the world has become so complicated that the information that people get tends to be significantly pre-filtered. And what that means is that you're not going to get a full picture, that you can't get a full picture. So even though, for example, I try to avoid it, I know that my internet news is pre-filtered. And worse than that, it's tending to turn into sort of crime news kinds of things rather than analytical news. So that's a problem for all of us, but it's part of what this shows. So let's say, for example, that this is true, that there are federal barriers to cannabis research, particularly if it's going to show that marijuana might have some benefits. Notice what this does. This means that the reports that you read on marijuana may be entirely accurate, but they may still be part of a very biased overall perspective. If all I do is fund work that shows a particular view, then I'm going to skew the debate regardless of whether the underlying scientific work is done well or not. So if most of the work on marijuana shows that it's harmful, does that mean the scientists were biased and bigoted and wrong? No, they could be perfectly good scientists. What it means is that people have figured out that if you control the funding and you skew the research, you can skew the debate even if the science is perfectly acceptable. This becomes yet another problem when you're trying to figure out what's real and what's not, which brings me to my last article. This comes out of a newsletter called Aeon. It's called The Reality Show, and it talks about the fact that 30 or 40 years ago, if people saw conspiracies or thought they were being tracked by rays, it was schizophrenia. It was a clinical disease. Now, if you think you're being tracked, it's Apple, right? So this is pointing out that part of the difficulty people are having today is precisely the fact that reality is fragmented, and that it is very difficult, if not impossible, in some cases, to be able to figure out what's real and what's not. Now, one of the ways I do that with technology is I look at whether or not the experiment was actually done and it accomplished everything that it purports to accomplish. So for example, I can read two articles, one of which says rapamycin is a drug that will extend life in humans. And the other says we gave rapamycin to nematodes, to worms, probably C. elegans, which is the one we usually use, and it extended their life. Which one is right? Well, they're both sort of right, but the second one is much more right. The experiment on the worm is only talking about what they found with the worms, And it turns out rapamycin does extend their lives. So in that case, they are reporting accurately what they did. When you talk about extending human life using rapamycin, though, you've jumped into a whole lot of assumptions. It may still be a good thought piece. That is to say, if it's phrased right, it says things like, it may extend human life. There's the possibility that this becomes part of a pharmacological project to extend human life. All of that certainly could be true. But it is not true that rapamycin extends human life. And yet, if you go online, you'll find places that would certainly assert that. Now, one of the things to remember, and you should remember this because a lot of people are beginning to self-treat with some of these materials. One of the things to remember is if something's powerful enough to do whatever it is people claim it's going to do, it's also powerful enough to do a lot of other things that they don't know about and aren't talking about. So rapamycin, for example, is used today as an immunosuppressant drug, which means it suppresses your immune system response. Now, you start taking rapamycin because you want to extend your life and you have a cancer, then what you're liable to find is that your immune system, which tends to hold cancers in check, gets repressed, and in fact, you die faster. I'm not saying that's going to happen. The science is not there to make those kinds of statements, but that's clearly a possibility. You're taking a very powerful drug. Might it extend your life? Yeah, it might. It might also cause things that we haven't thought of. So what's the purpose of all this? The purpose of all this is to get you thinking about where you get your information from. For most people today, information is pre-filtered so that more and more you're living in an echo chamber. You draw from sources that you agree with, you listen to people you agree with, you talk to communities you agree with, you're part of activist groups you agree with, and we don't have very many places left where you get exposure to broad perspectives that are different. So one of the things to be aware of is that reality is indeed changing. And that may be one of the greatest challenges to sustainable engineers and to all of us trying to solve today's problems. Thank you very much. I hope you've enjoyed the course. I hope you enjoy the rest of it. And good luck.